Hey everyone! Today we're going to explore one of the greatest mysteries of the universe, life on the moon. Have you ever wondered whether life could exist there, or if it's just a cold rock floating alone in the vastness of space? From the latest scientific discoveries to surprising theories, this journey will take you beyond anything you've ever imagined. Now, dim the lights, let yourself drift into space, and relax as we step together into this mysterious story. Gemini is considered the second largest moon in the solar system. It wasn't until more powerful telescopic lenses were directed at Jupiter, and its specific parameters were examined, that we realized just how massive Gemini truly is, earning it the title of a giant moon. So, during all the time that Gemini held second place, who was in first? That position belongs to the giant known as Titan. Since the early 1600s, some of the brightest minds had figured out ways to enhance their vision using these newly invented lenses. At first, they had little effect on the lives of ordinary working-class people. But when the great minds began using them, a new era was born. After Galileo Galilei pointed his telescope at Jupiter and discovered what were considered for planets at the time, the world changed. Before that, we only knew of one moon, Earth's natural satellite. Now, it was clear that other planets also had their own moons. This led to a new wave of discovery concerning the satellites of the remaining planets in the solar system. On March 25, 1655, Christian Huygens, a brilliant Dutch scientist, pointed his telescope toward Saturn, the farthest planet known to science at the time. On that fateful day, Huygens not only saw its magnificent rings, but also the majestic satellites orbiting that massive celestial body. And from that moment, we had Titan. Titan was the first natural satellite discovered after Galileo Galilei found the 4 moons of Jupiter, marking the 6th moon humanity had ever discovered in the sky. At first, this moon didn't bear the grand name it does today. Huygens simply referred to it as the moon of Saturn or lunar Saturni. By the end of the 17th century, as astronomers discovered more moons orbiting Saturn, a proper name was needed. Initially, following the scientific naming conventions of the time, Titan was assigned a number based on its orbital position around the planet. As such, Titan was named Satellite VI. However, this was bound to cause confusion as more moons were discovered, especially since Titan was clearly the 21st moon other than the 6th. Thus, naming by order would soon become problematic if we continued to discover more and more moons. In 1847, the astronomer John Herschel published the results of his astronomical observations, which he had recorded from 1834 to 1838 at the Cape of Good Hope. In those records, we found familiar names drawn from the sky, inspired by the gods, specifically the giants of mythology assigned to the moons of Jupiter. And from that, the name Titan was officially bestowed upon Huygens' moon. Through telescope observations, we can determine the orbital period of a moon around its parent planet. By recording this cycle, we can calculate how long one full orbit takes. For Titan, it takes 15 days and 22 hours to complete a revolution around Saturn. Titan shares an interesting trait with Earth's moon and several other large moons in the solar system. It is tidally locked to its parent planet, meaning one side always faces that planet. This results in various changes in weather conditions compared to our own planet, raising questions and curiosity about what life might be like on such a moon. However, despite the intense curiosity about Titan's characteristics, scientists had to wait nearly 300 years after its discovery to uncover new and fascinating details about it. In 1944, the great astronomer Gerard Cooper was the first to uncover intriguing information about Titan. Through his observations, he discovered that Titan was truly an unusual moon unlike other moons. It had an atmosphere, Thanks to this discovery, he went a step further and used reflectance to identify the basic substances present in its atmosphere. He discovered methane. The 20th century was an era of space exploration, and it didn't take long before new revelations about Titan began to emerge. The first spacecraft sent into space to study Saturn and its small companions was Pioneer 11, which passed by the planet in 1979. Before any space landings took place, astronomers on Earth had made specific estimates regarding the mass and size of Titan. This mission provided a chance not only to confirm those estimates, but also to delve deeper into the satellite's nature. It turned out that Titan's radius was as large as 2,575 kilometers larger than our Moon, and, surprisingly, even larger than Mercury. However, this same discovery helped us realize that Titan was not the largest moon in the entire solar system. Earth-based astronomical observations only allowed us to see its thick gaseous envelope. Thus, when looking at it and comparing it to Gamma's radius, we mistakenly believed it to be larger. Moreover, its orbital radius is also massive, with Titan lying 1,180,000 kilometers away from Saturn. Thanks to this mission, humanity obtained the first close-up images of Saturn and Titan. In 1980 and 1981, the twin spacecraft Voyager 1 and to flew past Saturn, and a new chapter of discovery began. With the imaging systems aboard both probes, we gained a more detailed look at this giant moon. It appeared as a dense smoky sphere with a mysteriously pale yellow hue, occasionally glowing with enigmatic shades of blue. In such a distant location, possessing an atmosphere, scientists predicted that its surface would feature rivers of liquid methane reflecting the sky, giving rise to those shimmering highlights. However, reality proved to be even more astonishing. As Voyager examined it more closely, traces of acetylene, ethylene, propene, and other organic molecules were detected, along with a large amount of nitrogen, which turned out to be the dominant gas in this pale yellow sky. At its great distance from the Sun, Titan's surface temperature remains around -179 degrees Celsius, which is cold enough for various gases to exist in liquid form and flow like rivers across its surface. This creates an environment somewhat similar to Earth, except the flowing liquid is not water, but rather organic substances kept in a liquid state by the extreme cold. If humanity ever wishes to colonize Titan and make it a new home, we would need to do a lot to terraform its environment. But it is exactly this idea that has led us to pay more attention to Titan than to many other moons. In 1990, the Hubble Space Telescope was launched into orbit, and by 1994, it turned its gaze toward Titan to begin its mission of exploring this massive moon. Through Hubble's observations, Titan appeared to have a solid surface, meaning it may have a rocky core wrapped in a strange atmosphere. From that observation, scientists theorized the formation of Titan's organic-rich atmosphere. One hypothesis suggests that, during the early formation of gas giants like Saturn, as they were still gathering gas, and not yet fully formed, smaller gas clouds were poured into large rocky bodies like Titan, which were then captured into orbit by Saturn's massive gravitational pull. Another theory posits that larger rocky bodies formed first, perhaps even a small planet, which was later broken apart by collisions in space, leaving behind fragments that became moons. Titan, being the largest surviving piece, retained a dense atmosphere as a result. As mysterious as this atmosphere is, it also presents a challenge. After years of observation with telescopes and multiple flybys, we still couldn't uncover much more about Titan other than confirming the uniqueness of its atmosphere. Ultimately, Titan remained just a fascinating moon without any major conclusions, until the decision was made to land on its surface and bring back more concrete results. that task would fall to the Cassini mission. But before we move on to the final chapter of this story, let's take a moment to acknowledge our video sponsor, Helios. Helios is a Vietnamese crafted silver accessory brand, featuring unique and creative collections tailored for young people. This Black Friday, Helios is offering customers discounts ranging from 25% to 60% on all products. This will be the final major sale of the year, giving you the chance to grab your favorite pieces at a great price. Silver and eyewear items will receive a 25% discount, while alloy products will be 45% off, only from November 23rd to 27th. Keep in mind, Helios rarely offers sales, so this is a rare opportunity to own Helios accessories at their best prices. Don't miss out. In 2004, the Cassini spacecraft was launched into space to study Saturn and the mysteries surrounding it. The appearance of another spacecraft orbiting the gas giant wasn't particularly surprising to astronomers, however. Cassini was equipped with the most advanced instruments of its time, and it came with a special gift for Titan, the Huygens probe, named after the scientist who first discovered Titan, was ordered to descend onto the Moon on January 14, 2005, marking the first ever landing on a celestial body located at the edge of our solar system. As soon as Huygens touched the surface of Titan, it sent back the first signals to Earth, and astronomers were overwhelmed with excitement. Through Huygens' lens, we discovered that Titan is a place remarkably similar to our own world. It has mountains, rivers, dunes, and even large clouds. These clouds are formed from methane gas and can produce rain, a rare phenomenon in our solar system. Evidence of methane rain can be seen in the erosion marks on Titan's rocky cliffs. However, these discoveries were not the most astonishing. When Huygens officially landed on Titan, the image it painted for astronomers on Earth was that of a surface resembling the bottom of an ocean. This wasn't enough to confirm that Titan once had oceans like those on Earth, but it was enough to raise questions about the possibility of an ancient ocean on this celestial body. Where there is liquid, there is a chance for life. Although water on Titan is frozen due to the extremely cold temperatures, it remains a potential clue in the search for primitive life swimming in methane. In short, Titan could hold answers to the origin of life, a glimpse into a primordial Earth we have never seen. Although astronomers were eager to witness more, the connection to the distant moon wasn't strong enough to prolong the research. Huygens wasn't equipped with solar panels to harness sunlight and extend its lifespan. It only had enough battery power to function for a limited time. After nearly 2 hours of activity on the distant moon, it officially shut down and sent its final data back to the Cassini mothership, which then transmitted it to Earth. Meanwhile, Cassini continued orbiting Saturn and capturing the most detailed images of Titan for humanity, until it retired in 2017, marking the end of its 13-year journey far from home. Therefore, from 2004 until now, the images Huygens captured on Titan remain the first and only ones we have seen directly from its surface. But even that alone is more than enough to give us hope for a future where we can explore this world more deeply. And that's exactly what we've been doing since the Huygens mission ended. Cassini continued to orbit Titan and Saturn to better understand the conditions there in preparation for a new mission. Meanwhile, on Earth, we have been working on a new project aimed at meeting longer-term goals than what Huygens could provide. And from there, we have Dragonfly, named after the very creature that inspired its design. The Dragonfly mission was created to study biological conditions on the surface of Titan. The reason it was modeled after a dragonfly is because of its wings, a complex system designed to take advantage of Titan's low gravity and thick atmosphere. allowing it to take off and travel to multiple locations on the moon, thereby diversifying the results sent back to the mothership. One major challenge that astronomers and engineers faced when developing Dragonfly was the issue of electrical power. Unlike previous satellites, whose missions mainly operated in orbit and required little electricity, allowing for solar energy to be used, Dragonfly cannot absorb the weak sunlight reaching Titan. Titan is not only so far from the Sun that the energy from its light is over 100 times weaker than what we receive on Earth, but it is also further dimmed by Titan's dense atmosphere. Therefore, installing solar panels would not only be ineffective, but would also make Dragonfly heavier and harder to launch. However, the solution isn't as difficult as one might think. We only need to look at how the Sun creates energy to find a way to save Dragonfly. Dragonfly will carry a nuclear battery, light enough for takeoff and powerful enough to keep its operations stable for an expected duration of about 10 years. With that battery, Dragonfly can fly up to 100 kilometers, activate drills, dig into the surface, and bring back samples for more detailed study than Huygens ever could. Currently, the instruments on Dragonfly still being developed and perfected before being placed on a rocket and launched into space. The estimated launch date is around June 2027. That means Dragonfly will land on Titan sometime in the near future, bringing back new discoveries about the origin of life. It will dig by itself, fly by itself, communicate with Earth by itself, and reveal to us a place that might one day be the home of humankind in the distant future. If that's not a promising mission, then perhaps we really need to explore the universe even more. And that was the story of Titan, the moon that could bring life to humanity in the future. Would you like to learn more about Saturn's other moons? Let us know in the comments below. And if you enjoyed this video, don't forget to click like, subscribe to our channel, and turn on the notification bell so you won't miss any of our future content. Thank you all for watching, and see you next time.